So the rest of the material in this section is just practice, meaning you have gotten everything you need, and all you need to do now is practice the power rule and the product rule and the quotient rule. And so what you should do is try to do any and all of the problems that you can, and then come back and watch this video and see what you got right, and learn from anything that you got wrong, and be smarter because of it. So let's start. Hopefully you did stuff and now you're ready. So notice I'm always going to use that derivative notation. So I have g prime of x. This is already set up to use the power rule. So I'm going to bring down the -3, and then I'm going to have x to the -4. This could also be written as -3 over x to the 4th. For the second one, and that's the answer, that's it. For the second one, f prime of x, we're going to bring down that 4/3 x. We're going to subtract 1, so subtract 3 over 3. We're going to be left with 1 over 3 as the exponent. Still a positive number, so that's all we need to do. For c, it's, just making us do a little bit of work here. We have the cube root of x. That's the same as x to the 1/3. Notice I still have it in my denominator like that. But in order to use the power rule, I need to just have x to the something. And so I need to have x to the -1/3. So now I have x to the something as opposed to 1 over x to the something. And now I can take my derivative. So h prime of x. I'm going to bring down that -1/3 x. And then you want to think about -1/3 minus 1 is -1/3 minus 3 over 3, because that is just 1. And that's going to be a -4 over 3. So that can be written a different way as well. This is also fine how you see it. It's no problem. And then we keep going. Okay, so for the next one, it wants us to find the first, second, and third derivatives. It's a polynomial, so we'll really just be using the power rule here, and of course the idea of taking the derivative of a constant. So our first derivative, bring down that 4x to the 3rd. We're going to multiply the 2 by the 3, x, and then that's just going to be x to the power of 1 plus, oh, wait a second, then we take that derivative of 4, and since that's a constant, it is gone. So this is all we have left at the first derivative. Then we take the second derivative and we just take the derivative of the first derivative. So we're going to multiply 3 by 4 to get 12, subtract 1, and we get -6. And then for our third derivative, we're just taking the derivative of the second derivative. So we'll have f triple prime, or the third derivative of f. We're going to multiply 2 by 12 to get 24. We'll subtract 1. And then, of course, the derivative of -6 is 0. So that's our third derivative, 24x. Notice we could take a couple more derivatives, but at some point we'll just get 0. At the bottom here, find the equation of the tangent line to the curve y equals 1 minus x squared that is parallel to the line 2x minus 4y equals 8. So in this case, you have to know what it means to be parallel. And for many people, they recognize that parallel lines have the same slope. So we want our line to have the same slope as this line. But we don't know what that slope is of that line yet, because that's not in y-intercept, slope-intercept form. So, a couple things we need to do here. Hold on. Let's think about this. So we need to think about what that same slope is. So we'll solve this for y. And use some division here. So the whole idea here is we want our line to have the same slope as 1/2. So of course there's some idea of slope happening here. So we need to think about the slope of this. No, that is not a great x. So there we go. So we need to think about the slope of our function, our curve, as they say. So we'll find y prime. And as you can see, the 1 is a constant, so it'll be gone, and we get -2x. So the big thing here is we want this thing, this -2x, to be equal to 1/2, because the line that we're looking for is parallel to that curve. So they need to have the same slope. So we have negative 2x has to equal 1/2. So if we divide both sides by negative 2, well, it's going to look a little bit weird, but like that, we get x equals, so we have 1/2 divided by negative 2, so that's the same as 1/2 times a negative 1/2. So we get negative 1/4. Okay, so the idea here is that tells us the x value of where this tangent line is going to be. So you have your curve 1 minus x squared. So you should think about that. That's an upside down parabola that's just shifted up by 1 because it's the same as negative x squared plus 1. And at negative 1/4, so I'm going to try to do this backwards. At negative 1/4, there's a tangent line. And that tangent line has a slope that is parallel to this line, you know, y equals 1/2 x minus 2, which will be down here. So these two lines are now parallel. But we need to find out the equation of this tangent line. That's what we're trying to find out. So we know we need slope and a point. We have the slope. It's 1/2. So we're set there. That's the slope. But we need our point, and right now we only have half of it. So now we need to find y. And so we just put that back into our curve. 1 minus negative 1/4 squared. And so that's going to give us 1 minus 1/16 or 15/16. I didn't say everything was pretty in calculus. So here we are. And so now that we have our point and we have our slope, we're ready to find the equation of that line. So we have everything that we need. So what I'm going to do is I'm going to go y minus 15/16 equals my slope, which is 1/2, times x minus 1/4. So that's x plus 1/4. And then I'm just dealing with some fractions, but that's okay. So I have y equals, you know what? Let me do 2 steps. I think that will be better for you. So I'll do y minus 15/16. And then we have the 1/2 x plus a 1/8. And then we're going to add the 15/16. So we have 1/2 x. We're adding 15/16 to 2/16. So that's a 17/16. So yeah, it is, you know, it's got some fractions there, but that's okay. So this is our equation of our line. So this equation is parallel, this equation of this line is parallel to this line over here. It's just that this line is tangent to the curve y equals 1 minus x squared. And that's why the derivative comes in to that situation. Whew, now we have more. All right, so so now we're taking the derivative if f of x equals this polynomial here times this radical. So there's a couple different ways to do this, and that's good to know. But one way to do this is just to understand that these are just two algebraic terms here. So you have x cubed plus 2x. You also have x to the 1/2. But x to the 1/2 can be multiplied by both of these two terms and, you know, be put into them. And then the derivative can be taken from there. So don't forget that sometimes you can manipulate algebraically to actually make your life easier. So when we multiply x cubed times x to the 1/2, we're going to get basically x to the 3 plus a half, so 3 1/2 or 7/2, plus 2 times x to the 1/2. This has a, you know, exponent of 1, so now you're doing 2/2 plus 1/2 to get 3/2. So x to the 3/2. And now you're ready to take your derivative, and it's just the power rule. That's all you have to do. So you might see that problem and think, oh man, I gotta use the product rule on that. But you don't, because you can simplify algebraically and then make your life a little bit easier. So when we do 3/2 times 2, we're just going to get 3x minus 1 to the 1/2. So here's our derivative with that, and it's great. But you could use the product rule. You're just going to make your life a bit harder when you use the product rule. So just know that it's possible, but you will make your life a little bit harder. So now we have, find the equation of the line tangent to this graph at this point. Now, I will tell you, we do not have a situation here where we can factor make our lives easier. This is a very big function, and it would require us using the quotient rule. I'll be honest, it will. But we can make our lives maybe a little bit easier, so I'll show you how. So we do need to find the equation of a line tangent to that point. So of course, two things we need. For the equation of a line, we need a point. So to find the point, we know we're going to have 1, and then we just really need to find f of 1. So if I'm trying to do, maybe I can just do that over here, f of 1. I'm going to have 3 plus 2 minus 7 in my denominator, 1 plus 2 minus 2. So it looks like my y value for my point on my line is going to be negative 2 over 1 or negative 2. So I got negative 2. But then we still need our slope. So this is where the quotient rule comes in. We're going to need the quotient rule here. So I have f prime of x. And so remembering what the rule is, the quotient rule that we have, we need to, exciting, we need to take the derivative of the top. And these, the two terms have to be done in the order, right? Because there's subtraction in the quotient rule. But that's okay. But, you know, for each term, you have two things that are multiplied. Either one can be done first. So I'm going to actually take the derivative of the top, which is 6x plus 2, and I'm going to multiply it by the denominator, x squared plus 2x minus 2. And I have a subtraction sign. And then I'm going to take the derivative of the bottom, the denominator, 2x plus 2, and I'm going to multiply it by the top, 3x squared plus 2x minus 7. And then remember, that's all over the bottom square. So here's where I'm saying you can make it a little bit easier. There is no reason to spend time like multiplying this out, doing a whole bunch of work, because all you need to know is what the slope is at that point. So you can just plug in 1 to this derivative and get your slope without having to do a whole bunch of simplification first. There's no reason for it. All you need to find out is the value at 1. So if we put 1 in, we get 8 times 1. See how simple that is? Minus 4 times negative 2 all over, oh, pretty simple there, 1 squared. So obviously a lot easier than a lot of other things. No need to simplify here. So it looks like we get 8 plus 8, which is 16 over 1. So we get a slope of 16. And so now we're ready. Now we're ready to find that equation of the line. We have everything we need. We've got the point, we've got the slope. So now we can do y minus a negative 2, which is y plus 2. Our slope is 16 times x minus 1. And that's going to give us y plus 2, 16x minus 16, or y equals 16x minus 18. And there is our equation of the line tangent to the graph at that point. All right, just a couple more problems here. So now we've got to find the derivative of j of x. All right, so this is another one of those situations where you might look at this and be like, oh man, I need the quotient rule. Well, actually you don't, because what you can do, because you're just dealing with all polynomials here, you can actually square the top, and then that's divided by the bottom. And then now, because you're dividing by just one term in the denominator, you can just divide it into each piece and end up with x squared minus 2 plus 1 over x squared, or x to the negative 2. Then now you're ready to take your derivative, and you're going to have 2x minus, well, the derivative of 2 is 0, so minus 0. And then that third piece, you're going to bring down the negative 2x to the negative 3. This can also be written, if you want, as minus 2 over x cubed. So a couple options here. But make it easier. Make it easier on yourself. That's the way to go. Don't spend time trying to do a crazy quotient rule on this because it's just not needed. Okay, so the last problem here is let f of x, big F of x, be f of x over g of x. And it says find the derivative of this big F of x, but use the product rule. And you might be thinking, well, that's weird because I have two things divided by each other. Why am I using the product rule? So one of the ways to do this, which I think is a good way to go about it, is to multiply both sides of this by little, this little g of x. So I'm going to have f of x times g of x, this big F of x, times g of x, and that's going to equal f of x. And then I'm going to use the product rule to find the derivative. So what that's going to give us is f prime of x, big F, times g of x, plus big F of x times the derivative of g of x equals f prime of x. So I'm basically just taking the derivative straight across, but I need the product rule over on the left side. That's over here for you guys. So now I just need to solve this for f prime of x, because that's what I'm trying to find is big F prime of x. However, I want my problem to be in terms of f of x and g of x. So a good idea, the next thing we need to do is remember that big F of x is given to us. It is here. So I'm just going to rewrite that. Okay, so I've replaced big F of x with what it's equivalent to. Now, everything I have there is just, besides f prime of x, is just this, f and little f and g. So now we want to solve for big F prime. So a couple different ways we can go about it. I'm going to bring it, let me do one more line here. So I'm going to subtract the term that does not have the big F prime. So I'm going to bring it over to this side, f prime of x, and then subtract that whole thing, f of x over g of x times g prime of x. And then, of course, to solve, we need to have f prime of x by itself. So I'm going to have to divide both of those pieces by my g of x. So I'm taking my g of x here, dividing both sides. So I'm going to have f prime of x over g of x minus f of x, and I'm going to bring that g prime of x up like that, because that's where it is, because as a fraction it's over 1. And then in my denominator here I have the g of x, but also another g of x, right, because I divided that piece by g of x, so g of x squared. So you might be able to see where we're going here. In order to combine these two things, so we have the simplified version, we need a common denominator. So I need a g of x, I need another g of x on that first term, so that this is g of x squared. And then my other term already has the common denominator, g of x squared. And now for the grand finale, now we can combine both of the terms. We get f prime of x times g of x minus f of x times g prime of x divided by g of x squared. And hopefully you recognize this as the quotient rule. So we've basically just proven the quotient rule, but we used the product rule to do it. So that is section 2.3.